So now what we're going to look at is how we can combine functions. And there are many different ways that we can combine functions. The first way we're going to look at is if we want to do the sum or difference of two functions. All right, so adding and subtracting two functions is not too bad because it does exactly what you would think it does. For first thing is, let's look at some notation. So if we want to signal that we're doing the sum of two functions, then we would do f plus g of x, which in meaning is just f of x plus g of x. And if we want to do the difference function, then it's f minus g of x, which is just f of x minus g of x. All right, so that's how we describe it. So now let's talk domains. Remember, domains is about what is allowed in. So if I'm going to put some x into my sum function, it's going to have to be able to go into f, and it's going to have to be able to go into g. So the domain for this would be the domain common to f and g. So basically, it would have to be whatever domain is in both f and g's domain. So whatever's common to the both of them. And the same thing for the difference. It's the domain common to f and g. So let's look at an example and see how this would work. Let's say we have f of x is x squared plus 3, and g of x is the square root of x plus 2. Let's first talk domains. All right, the domain of x squared plus 3, is there any restriction on what values can go in there? No, it's a polynomial. It can take all real numbers. G of x, on the other hand, if we're going to stay in the reals, we can't have negatives under that square root. So we can start with -2 and go all the way to infinity. So our domain would be -2 to infinity, and that will avoid any negatives under the square root. Okay, so how does that affect our sum and difference functions? Well, first let's just see what the functions come out to be. So the sum function again is just the sum of the two functions, f of x plus g of x. So you would simply add them. So x squared plus 3 plus square root of x plus 2. And the difference function would just be subtracting them. So x squared plus 3 minus the square root of x plus 2. But for each one, let's talk about its domain. So the domain of the sum function, we said, has to be what's common to both the original domains of f and g. Well, f had all real numbers, so really no restriction. G had the domain -2 to infinity. So the portion that's common to both of those is g's domain, because the real numbers have everything in it, and g has a domain which starts at -2 and goes to infinity. So that's the part that's common to both of it. And we said that the difference function would have just the same one. Okay, so that's our sum and difference function. What about product and quotient functions? Now, if we want to take two functions, multiply them or divide them. Again, notationally, we would say the product fg of x is f of x times g of x. And the quotient function f over g of x is f of x over g of x. All right. So that sounds pretty reasonable. And what about their domains? Well, again, let's look. If you're going to put some value of x into the product function, it has to individually go into f, and it has to individually go into g. So you'd need the domain common to f and g, because it has to be able to go into each one of them. So if there's any number excluded, say from one of the two functions, it has to be excluded from the product function. All right. The quotient is similar, but has one little wrinkle. All right. So if you want to put an x into the quotient function, it has to go into f and it has to go into g. So we start with the idea that it's the domain common to f and g, but there's one additional restriction. Notice that you have a denominator now. G of x is now in the denominator. So you need to add a condition and such that g is not equal to 0. Because what we can't have here is we can't have a denominator of 0. So again, let's take these two functions. We looked at this before. Domain here is all real numbers. The domain here is -2 to infinity. All right, so what would it mean to do these product and quotient functions? Again, they're pretty easy to build. If you want the product function, fg of x, it would be f of x times g of x. So it would just be x squared plus 3 times the square root of x plus 2. And if you wanted the quotient function, it would just be f of x over g of x. So it would be x squared plus 3 over the square root of x plus 2. And let's talk domains. We said the domain of the product function was the domain that's common to both of these. Well, again, that's the -2 to infinity because that's already part of all the real numbers. So -2 to infinity, including -2. Now, when I go to the domain of the quotient function, it starts out talking about the domain that's common to f and g. So I would start out with the idea that it's -2 to infinity, including -2. But I have to make one further check. I have to make sure that g doesn't become 0. But g would become 0 when x is -2. So I have to get rid of that. So that can't be in my domain. So my domain is actually going to be open -2 to infinity because I can no longer include -2 in my domain. So there's how we can do sum, difference, product, and quotient, both building the function and figuring out what the domain should be.